Hi guys, in this video we're going to look at writing electronic configuration, and we will also look at how the spin diagrams, which are the electrons in boxes diagrams, are drawn to represent the electronic configuration. Let's look at the element argon. Right, so we have argon. It has an atomic number of 18. Let's look at writing its electronic configuration. And we're keeping in mind the three rules written on the right, which state lowest energy orbitals fill first. There are no more than 2 electrons in an orbital, and that electrons will occupy degenerate orbitals. These are orbitals of equal energies. Electrons occupy these orbitals with parallel spins before electron pairing can occur. Right, before we go into writing our electronic configuration, I just want to come to the right here and list our orbitals in increasing energy. So we have 1s, 2s, 2p, 3s, 3p, then we have the 4s, followed by the 3d. So let's figure out what's happening with our electronic configuration for argon. Right, so we have our 1s subshell. Right, so this will fill first, and one electron fills in and another will fill in. Right, so it pairs up before electrons can fill into a higher energy level. So that's the 1s. Electrons will fill into the 2s subshell before filling into the 2p subshell. So far we have 4 electrons, we have 14 to go. 6 electrons in total will fill into our 2p subshell. Right, each p subshell consists of 3 orbitals. These electrons will fill in singly with parallel spins before spin pairing can occur. So we have 6 in the 2p subshell. Electrons will fill into the 3s subshell. Right, so we have 10 and 12. We just have 6 more electrons to go. And these 6 electrons will fill into the 3p subshell. I want to draw the spin diagrams, which are our electrons in box diagram, where I will represent an electron with a half-headed arrow. So let's draw our electron in box diagram, and we're going to do so by, we can draw the box, so you can draw it, and we're going to draw a box for each each subshell, to show how the electrons fill in. So I have my 1s, 2s, 2p. I'm going to draw as 3 boxes together. Remember, the orbitals in a 2p subshell are degenerate or equal in energy. Next up, we have our 3s, followed by 3p. So let's draw in our electron in box diagram. Our spin diagram, to show how electrons will fill into the orbitals and subshells. So we say that an electron will fill into an orbital, right, the lowest energy orbital, and that there are no more than 2 electrons in an orbital. So our lowest energy orbitals will fill first, right? So this means an electron will not fill into the 2s. It will go into the 1s because the 1s is lower in energy than the 2s. So I have 2 electrons here. This is a spin pair. An electron will then fill into the 2s subshell. Right. Another electron will fill in, that is, it will pair up. And this is because lowest energy orbitals will fill first before higher energy orbitals fill up. We go to our 2p subshell, where electrons will occupy these degenerate, right, or equal energy orbitals singly before pairing up. Right, so I have 6 going into my 2p subshell, and it's going to go in this order: 1, 2, 3. So electrons will fill in of parallel spins before spin pairing occurs. Electrons will then fill into the 3s subshell, and then the 3p, 1, 2, 3, 4, 5, 6. And this is our electron in boxes or spin diagrams, which show the electronic configuration in terms of how the electrons arrange themselves in pairs by showing the electrons are of opposite spins.